Okay, kids, this video is going to cover the concepts of finding area of polygons, regular polygons, as well as irregular polygons, okay, or polygons that are kind of a composition of several polygons, all right? Now, the first thing we want to talk about is finding area. Area is like the space that something takes up, but only on a flat surface, okay? So like the area of this shape, okay, could be measured in square units, all right? Now, when you measure and you calculate area, okay, area equals the length times the width. Okay, area equals the length times the width. So if I wanted to find out the area of this square, a couple things that I could first stop and think about is that this square has all congruent sides, all equal sides. All right, so in this case, all I'd have to do is really measure one side of this, and then I could make those my length, and that measurement my length and my width. All right. Now, we're going to measure in centimeters, which means I'm looking for square centimeters. Now, when you measure something like this KNEX, it's not a nice, neat package, all right? In fact, it's kind of difficult because of the edges, all right? So one of the things that I like to do is I kind of say you're either going to measure on these outside connectors because those are a consistent measuring point, or you need to measure from rod to rod. In this case, you'd want to measure, because you can, you'd measure from the outside of the red connectors, all right? So when I measure, and I put my ruler on here, okay, you can see that I line up my 0 right here, and then I measure over, and this stops right at 6, okay? And so this would be 6 centimeters long. So my length would be 6 centimeters, okay? And then, of course, because it's a square, I know that if I measure my width, I will also get 6 centimeters right there, okay? Now, these are not exactly precise, but they're pretty precise, okay? So now all I have to do is multiply 6 by 6, and I get 36. When I do that, that tells me I have 36 square centimeters. And when I write it like this, 36 cm2. That means square centimeters. All right? So that's how we figure out area. All right? Especially when we're measuring KNEX, we have to be real flexible. Okay? So let's try another one. Okay? Here is a rectangle. Okay? And we're going to do the length times the width again. Okay? So when I look at this and I measure it, I'm going to measure my length. Now, because I have these nice clean corners, I can measure from corner to corner, from side to side here. Okay? And it's a parallelogram, which means opposite sides are parallel and opposite sides are congruent, so I could actually measure anywhere in here to get my length and width, okay? But I'm going to measure on the corners because I have 2 red connectors there. Now when I measure this, because I am measuring the KNEX, I'm going to the nearest centimeter, I can go to the nearest half centimeter. So in this case, I see that I have 1, 2, 3, 4, 5, 6, 7, 8, but I extend past the 8 about halfway between the 8 and the 9. So I would call this 8.5, okay? 8.5, or 8 5/10 of a centimeter, okay? So again, my formula for finding area is length times width, okay? Length times width. So my length in this case, for this shape, is going to be 8 5/10 of a centimeter. Okay? Now I need to measure my width. Now, you might recall what the width of this was, and you can see how they're congruent, they're the same width, but I'm going to measure it just to be sure. So in this case, my width, once again, my width comes out at approximately 6 centimeters. That's pretty close to 6 centimeters right there. All right, so it is 8 5/10 times 6. All right, so if I were to actually do the math here, I'd have 8 5/10 multiplied by 6. 6 times 5 is 30, carry the 3. 6 times 8 is 48 plus 3 gives me 51 centimeters. Okay, 51 square centimeters. So cm2. All right, so that's how you would do that. Now, on occasion, you will find that you get a shape like this when you're measuring area for KNEX. I mean, clearly there's not any defined corner here or defined corner here. You have a defined corner here, but nothing here. Okay, so you're going to have to really use some real-world measuring skills to do this. All right, so in this case, what I would do is I can still apply my area formula, length times width equals area. So I can still use that formula, okay? But my measuring has to be a little bit more adapted to the situation. In other words, because this is a parallelogram, I can't measure easily from corner to corner. I suppose I could measure inside these circles here if I wanted to, but you know what I can do is I can just go from the outside of the white connector to the outside of this white connector, all right? And that would give me my area, my length, okay? So in this case, when I measure it, you'll see that I start with the 0 right here on the edge of the white, and then as I go down across the ruler, keeping the ruler straight, I have 15 and a half to the outside of the white rod here. So I have 15 and a half to this point right here. 15 and a half. So my length is going to be 15.5 centimeters. Okay? Now my width, okay, the width I can do the same way. I can measure from the edge of my red rod to the edge of my red rod. And when I do that, lining up things, I can measure it at any point, okay? And when I do that, I see that I have 6 centimeters. It's 6 centimeters, almost exactly. So now I can say my length is 15 5/10. My width is 6 centimeters, okay? So when I do that, I can just simply multiply 15 5/10 by 6. 6 times 5 is 30. 6 times 5 is 30 plus 3 is 33. Carry the 3. 6 times 1 is 6 plus 3 is 9. So my area would be, for this case, 93 square centimeters, okay? And so that's how I would come up with my answer, 93 square centimeters. Now, occasionally, what's going to happen is you're going to be asked to find the area of a shape that looks like this. Now, when you look at this shape, you want to break it down into shapes that you can actually measure, okay? Now, that's called decomposing, okay? This is decomposing, is when you look at something like this and you say, okay, I want to find the area of this, so I can say there's a square right up here, and there's a rectangle right here. So when you find the area of this shape, you find the area of this part right here first. And then you find the area of this part right here. So you find the area of a square, you find the area of the rectangle, and you add them together to get the total area. That's called decomposing a shape. All right? So, let's go ahead and give that a try. Let's see if we can't decompose this shape. All right? So, when you do this, I'm going to take the square first, okay? Because I know it's a square, and if I measure across, I will see that I have 6 centimeters. All right? So it's a square, and it's 6 centimeters wide, which means that it's got to be 6 centimeters high, or 6 centimeters long. So it's 6 wide, 6 long. So the first part that I can do, okay, is going to be 6 times 6, and that would give me 36 square centimeters. The next thing that we're going to do, okay, is we're going to find the area of that rectangle. Okay, I've already done the square up above, so now I'm going to do this rectangle. Now, in order to do that, I can measure, because I can't really get a good measurement on the corners, I'm going to measure from this white rod to this yellow rod. And when I do that, I will get a total of about 11 centimeters. So it's about 11 centimeters. So my length is 11 centimeters. And my width, if I remember from my square, it's the same distance because I have a white rod, just like I did here and here. I know that it should probably be 6 centimeters. And when I measure it, you can see that it comes out, when I measure it from the yellow rod up, it comes out to 6 centimeters, right there, 6 centimeters. Okay? So I know that my width for this rectangle is going to be 11 by 6. And I multiply. And that would give me 66 square centimeters. Now the story doesn't finish there, because what I did was I decomposed these shapes. And now I have to add those shapes together. So I'm going to take 36 plus 66 and add them. So I get 12, regroup, I get 102. So my answer for the area of this shape is 102 square centimeters. Okay? And that's because I decomposed it, found the area of a square, area of a rectangle, added those together. All right? Let's give it another try. Let's take a look at this one. Okay? A little bit different, same conditions. I have a shape that I need to decompose. And if you look at this shape, you'll see that I have a rectangle here, and I have a rectangle here, because when you look at it, that's what it looks like. So you can actually divide this up into a small rectangle and another small rectangle. You decompose it, okay? Now, in this case, I'm going to take my math, and I'm going to do my measuring. Whoops, covered that up there, okay? So first I'm going to do my small rectangle up here. And when I do my small rectangle, I measure it across, like so, and I see that I get 8 centimeters. All right? So my length for my small rectangle is 8 centimeters. Okay? Now I want to measure the width of my rectangle, which gets a little bit more difficult, but in this case I can measure from here to here, okay? From here to here, and get that measurement. And when I do that, I measure it, and it comes out to about 6 centimeters, which makes sense, okay? That makes sense. See, and so I'm measuring from inside here to outside there, and that's 6 centimeters. So I know that the small rectangle that I decomposed has an area of 48 square centimeters. So now I have to figure out the area of my big rectangle. All right, my larger rectangle, so I'm going to establish the length. Put my measurements there, and when I measure, I can see that it comes out from here all the way down to there, and that is a total of 15.5 centimeters. Okay, so my length is 15.5, and my width at this point, I'm pretty sure it's going to be 6 centimeters, and sure enough, it is 6 centimeters. From 0 up to here is 6 centimeters. And notice how I'm measuring the rods, not the tips. I'm measuring the rods, not the tips of the connectors, because they stick way out everywhere. So I'm measuring the actual rod distance. And that works because it's a parallelogram. All right, so that's 6 centimeters. I'm going to have to do a little math off to the side. Multiply. 6 times 5 is 30. Carry the 3. 6 times 5 is 30. 33. Carry the 1. 6 times 1 is 6. Plus the 3 is 9. So we have 93 centimeters. Double check. 6 times 5 is 30. Carry the 3. 6 times 5 is 30. Plus 3 is 33. 93. So I have 93 square centimeters. Okay? So now I add those up. 48 plus 93. 8 plus 3 is 11. Carry the 1. 1 plus 4 is 5. 5 plus 9 is 14. And when I do that, these are all whole numbers. I don't have to worry about a decimal. So the area for this shape comes out to 141 square centimeters. All right? Okay. So anyways, that is how you find the area of a irregular shape, okay, or a polygon that needs decomposed. Okay? Decomposed means you break it into smaller shapes that are easier to work with. All right? Smaller shapes that are easier to work with, such as that. Okay? All right, there you go. Hope you learned something from this video.